Alright, here's our example where in the first fraction it's 1 over x squared plus 2x minus 3 plus another fraction, x plus 2 over x plus 3 equals to 1. Alright, now it looks complicated, but in fact it's very simple once you understand the patterns and the process. In order to start solving, first is we're going to simplify. And what I mean by simplify is if you can factor. The reason I say factor is because we have a quadratic equation here in the denominator, x squared plus 2x minus 3. Now, if you were to factor according to what you have learned for factoring trinomial in chapter 5, when you factor, you should have this: 1 over x plus 3 times x minus 1. So, when you finish factoring, that's what you should have. And now bring down the rest of the equation. Equal to 1. Alright, now let's take a look at our LCD. Lowest common denominator. Now, this fraction has x plus 3 and x minus 1. The second fraction has x plus 3. So we know for sure that x plus 3 is part of our LCD. Now, what the first fraction has that the second one does not is x minus 1. So, this fraction is fine according to our LCD. It has both factors. The second one does not. It only has x plus 3 and we need an x minus 1. So what's going to happen is I'm going to multiply the second fraction by x minus 1. So the first fraction will stay the same. And then let me write out the second fraction. Now the reason I'm putting x plus 2 and x plus 3 in parentheses is, according to our LCD, the second fraction has x plus 3 but missing x minus 1. So I'm going to multiply the numerator and denominator by x minus 1. While it equals to 1. Alright? So, now, these two fractions has both x plus 3 and x minus 1. What we're going to do here is that we're actually going to FOIL in this numerator. So, this is what I'm pertaining to when we're doing more steps. So, the first fraction will still stay the same. X plus 3, x minus 1, equal. Now when you FOIL, you're going to get x squared plus x minus 2 over x plus 3 times x minus 1 equal to 1. Alright. When you combine these two fractions together, because they have the same common denominator, sorry, this is supposed to be a plus. So, as I was saying, since these two fractions has common denominator, they both have x plus 3, x minus 1, we can combine it as one fraction. So it's going to be 1 plus x squared plus x minus 2 over our factors, or also known as our LCD, equal to 1. Alright? Now, before we do any kind of solving, the only problem right now is that this is equal to 1. What we're going to do next is we're going to convert 1 into a fraction, Now the reason I'm doing this is because when we're dealing with rational equation that has quadratic parts where multiple fractions like this, once we have a common denominator, we're mainly going to just focus on the numerator part. So here, I'm going to keep this the same for the time being, but we're going to change this 1 into a fraction. So let me illustrate that we're changing this into a fraction. And then when we're solving for a quadratic equation, then we need to have the same denominator. So again, the first fraction, the one on the left, will stay the same. So 1 plus x squared plus x minus 2 over common denominator, so x plus 3, x minus 1, equal, so 1 times x plus 3 times x minus 1 over 1 times x plus 3 x minus 1. Alright, so once both sides has the same denominator, then you just mainly focus on the numerator. That's it, the numerator. So let me write just the numerator up here. Again, the reason I convert into a fraction, so that way we can multiply the right fraction by our LCD, so that way on the denominator for both sides it's the same. Once they're the same, then when you're trying to solve, you're just going to look for the numerator. That's it. Alright, so again, I'm just going to write the numerator up here. So it's going to be 1 plus x squared plus x minus 2 equal, now here, since there are two factors, that's from the LCD, these two factors came from x squared plus 2x minus 3. So eventually you're going to have to FOIL. So you're not going to write it as just x plus 3 times x minus 1 on the right side. You're just simply going to write the quadratic equation part right here, x squared plus 2x minus 3. So I'm going to write x squared plus 2x minus 3. So we have 1 plus x squared plus x minus 2 on the left side, and then x squared plus 2x minus 3 on the right side. Next is we're just going to start solving. Here, I can actually combine my 1 and my negative 2 on the left side. So on the left, it will be x squared plus x minus 1 equal x squared plus 2x minus 3. Alright, from there, let's start by doing opposite operation. So say I want to cancel out the x squared on the right. To do that, I'm going to do minus x squared minus x squared. So the x squares will cancel out. So on the left, I will only have x minus 1 equal, on the right, 2x minus 3. Alright, after that, say I want to cancel my 2x on the right, so I'm going to subtract by 2x on both sides. So x minus 2x would be negative x minus 1 equal to negative 3. Alright, let me erase to make more room. Here, I'm going to add 1 on the left side and 1 on the right, so that way I can get negative x by itself. Negative x equals to negative 3 plus 1 would be negative 2. And then from there, I'm going to divide by negative 1. Divide by negative 1. So x equals to positive 2. Alright, so that would be our answer. Now before we are done, before we move on from this example, we have to check our LCD. Now here's why. Our answer, x equals 2, has to be applicable, meaning that you have to be able to plug into the denominator and the numerator for the whole equation. So let's take a look at our LCD. This pertaining to 6.1, excluded values. So, excluded value. Let's talk about where if we want to avoid our denominator becoming 0, from our LCD, x plus 3 cannot equal to 0, and x minus 1 cannot equal to 0. So when you're solving for both excluded values, here I'm going to subtract by 3 on both sides. So x cannot equal to negative 3, and here I'm going to add 1 to both sides. So x cannot equal to positive 1. So let's check our solution. And then let me underline these two. These are our excluded values. X equals to 2. It does not match with our excluded value. That means that this solution is perfectly fine. Had you did all this work and then reached the end where had this been x equal to negative 3, it won't work, it would be no solution. Or had you did all this work and you came out to x equals to positive 1 and it matches with our excluded value, then again it would not work, therefore it would be a no solution. So our LCD not just only help us to combine fractions to find lowest common denominator to help us solve for our answer, but to also help us find excluded values as what we did in 6.1, and then double check when you did all this work, you want to make sure that your answer does not match with the excluded value. If it does, that means that it's no solution. So since x equals 2 does not match with negative 3 nor positive 1, this is our final answer.